Have you ever seen an AI video that looks like it's straight out of Hollywood, and then you try it, and you get a blurry mess? Well, today, we're going to pull back the curtain on that whole process. We're talking the entire journey, from a simple idea you type in, all the way to that perfect final pixel on your screen. Yeah, if that frustration sounds familiar, you are definitely not alone. And here's the secret, it's not just about which AI model you pick. The real magic, or the lack of it, comes from this whole pipeline, this entire journey that takes your idea and turns it into something you can actually watch. Okay, so let's do it. Let's walk through that journey step by step and really figure out what it takes to create AI video that looks, professional. All right, so layer one, speaking the AI's language. Everything, and I mean everything, starts with your prompt. But here's the thing. To get those amazing results, you can't just talk to it normally. You have to learn its secret language. And guess what? That language is cinematography. Just look at the difference here. On one side, a woman walking in a garden. It's fine. But on the other side, you give it the details, the shot type, the camera lens, the lighting. You're not just giving it an idea anymore. You're handing it a professional blueprint. And that's how you get something that looks truly cinematic. So how do you do that? Well, top creators use a framework, kind of like a cheat sheet, that breaks it down into these 6 layers. It literally forces you to think like a film director, right? You start with the basics. Who's in the shot and what are they doing? And then you layer on all the technical details that really make it pop. And this is the absolute key to understanding this first layer. Why does this work so well? Because these AI models have been trained on mountains of professional film and video data. So when you use terms like medium tracking shot or golden hour, you're not just trying to sound smart. No, you're literally speaking the AI's native language. That's how you unlock what it's truly capable of. Okay, so you've mastered the prompt. You're speaking the language. But even the most perfect prompt in the world won't help you if the AI itself wasn't trained on the right stuff. And that brings us to our second layer, solving this huge problem called the data dilemma. You see, for the longest time, teaching an AI about human motion was just a massive headache. The data that researchers had to work with, honestly, it was a mess. It wasn't diverse at all. You'd get videos all shot in the same boring room. It wasn't clean, it was expensive to make, and you had all kinds of privacy issues, just a total bottleneck. And here's what happens when your data is that bad. You get what Andrej Karpathy talked about. You tell the AI to make people jump, and they all jump in the exact same weirdly robotic way. The AI has learned this super narrow, limited version of reality, and it just can't generalize. So, what's the solution? Well, it's a really clever technique called pose transfer, and it is a total game changer. Basically, you can take the motion from a person in one video and just apply it to a completely different person or character. This lets you create a massive, nearly infinite amount of brand new, high quality, and totally controllable training data. It's synthetic, but it's perfect for the AI. And you want to see the impact? Just look at this. The results are absolutely stunning. On this one data set, with the original messy data, the model's accuracy was only 20%. But when you add in that high-quality synthetic data, boom, accuracy jumps all the way up to 50%. That's more than double the performance. It's huge. The breakthrough here really comes from these new hybrid models. Think of it this way. You've got your generative models, like Diffusion, which are kind of like these brilliant, photorealistic, but unpredictable artists. Then you have simulation engines, like in CGI, which are like meticulous architects. Total control, but they don't always look real. Well, these hybrid models give you the best of both worlds. The realism of the artist with the control of the architect. Okay, so now we have a fantastic prompt and a model that's been trained on really great data. But what happens if the video we want isn't, well, slat? What if it needs to have real depth, real dimension? This is where things get really futuristic. This brings us to the absolute cutting edge, 4D generation. And what that means is taking a single, flat 2D video of an object and using AI to generate its full 3D shape, its appearance, and its motion through space over time. You're basically creating a dynamic, interactive 3D asset from a simple video clip. Now, this is an incredibly difficult problem to solve. I mean, think about it. There are no big datasets of 4D objects for the AI to learn from. It's like asking you to build a perfect 3D model of a car, but you only get to see one picture of it from one angle. That's what the AI has to do. It has to figure out what the back and the top look like, even though it's never seen them. So how do they pull this off? Well, models like SV4D use this really sophisticated architecture that basically forces itself to be consistent. It has these special attention layers. One layer makes sure the object looks coherent across the image itself, another makes sure it's consistent as the camera moves around it, and a third makes sure it's consistent over time as it moves. It's all about maintaining that illusion. And to generate these long, consistent 4D videos without, completely running out of computer memory, they use this clever trick. It's kind of like a connect the dots strategy. First, the AI generates a few key anchor frames, the most important poses. Then, it uses those anchors as guideposts and goes back to fill in all the frames in between. It's a super efficient way to build a smooth, long animation. All right, we have come a long way. We've gone from a prompt to a well-trained model, and we've even generated a 4D video. But there's one final crucial piece of the puzzle. How do you make sure that incredible video you just created looks perfect on any screen? Because here's a problem you've probably noticed yourself. The video you create can look amazing on your high-end TV, but then on your phone it looks dull and washed out. And that's because every single device has different capabilities for things like brightness, color, and contrast. This is where a standard like HDR Vivid comes in. See, older standards used static metadata, kind of a one-size-fits-all set of instructions, but HDR Vivid uses dynamic metadata. That means it sends information that can change for every single scene or even every single frame of the video. It's way, way smarter. So what does that smart metadata do? It allows the display to perform what's called intelligent tone mapping. The best way to think about it is like a custom tailor for your screen. It takes the video and adjusts it perfectly to your specific device's capabilities, all while making sure it preserves the original artistic intent of the creator. It's brilliant. And the result? You get a consistent, vibrant image across all your devices. The colors don't get distorted when the brightness changes. They stay true to the original source. This is that final, crucial step that guarantees the picture on the screen is just as flawless as the creator envisioned it. So let's recap. From that first creative spark of a prompt, through the data, the 4D modeling, all the way to the final pixel hitting a screen, the modern video pipeline is this amazing fusion of human artistry and incredible computational power. And this whole process really represents a fundamental shift in how we think about media. We're moving away from just capturing reality with a camera to actually computing it from scratch. And that leaves us with a really big question for the future. As we move deeper into this new world, what is it going to mean to be a creator?